Hello everyone, my name is Rudrani and I will be teaching you pointers in C++. So when we talk about pointers, we are actually talking about variables that store the address of another variable. इसका मतलब है कि pointer एक ऐसा variable है जिसमें हम एक address store करते हैं एक दूसरे variable का. Like any variable or constant, you must declare a pointer before you can work with it. ऑब्वियसली अगर आप एक वेरिएबल डिक्लेयर नहीं करोगे तो आप उसको यूज नहीं कर पाओगे. उसी तरह अगर हम पॉइंटर पहले से डिक्लेयर नहीं करेंगे हम उस पॉइंटर को प्रोग्राम में यूज नहीं कर पाएंगे. द सिंटैक्स ऑफ डिक्लेयरिंग अ पॉइंटर इज data type, whatever data type it could be, int, float, double, char, anything, asterisk, pointer name, and then pointer name is equal to address of that variable. So here you must have seen that we are using two symbols, asterisk and ampersand. Here asterisk is actually the dereferencing operator. When we use the dereferencing operator, it refers to the content of the referee. Dereferencing operator से हम जो content है, actual जो content तक refer कर रहे हैं, उस तक हम पहुंच पाते हैं. और जो address of operator है, that is actually to get that address. हमें अगर किसी variable का address चाहिए, we use ampersand. We will understand this better with the help of examples. Whenever we declare a normal variable, we write a data type, variable name is equal to whatever the data you want to feed in. For example, int a is equal to 10. int data type हो गया, a एक variable का name है और 10 एक value है. So अगर हम एक pointer use करते हैं तो pointer को declare करने के लिए we first have to mention the data type of the pointer. Now you must note this. A pointer variable contains the address of another variable of the same data type. Means if the variable we are pointing towards is an integer, then the pointer should also be an integer. If the variable we are pointing to is a char, then the pointer should also be a char. See, normal variables are called direct referencing because we are directly accessing them. If we write cout a, after declaring int a is equal to 10, if we write cout a, तो हमें directly a का value मिल जाएगा, that is 10. But अगर हमें एक pointer के through a को access करना हो, so we have a different process. That is why we call pointers as indirect referencing. हम indirectly pointers से a को refer करते हैं. So obviously we must make sure, otherwise हमारे program में compilation errors आएंगी. We should make sure that the pointer should always be of the same data type as the variable it points to. Here we can see that pointer p is pointing to variable a. Variable a has value 10 and pointer p stores the address of a. So अगर address of a is suppose in memory is 10,000, तो यहाँ पे address of a will be also 10,000. So let me show you the illustration using a diagram. Here int y is equal to 5. This is a normal variable declaration. Int pointer yptr. This is the name of the ptr. Yptr is the name of the pointer. Yptr gets the address of y, which means pointer yptr now points to y. इसका मतलब ये हुआ, हमने जब वेरिएबल y डिक्लेयर किया उसमें वैल्यू असाइन किया 5, फिर हमने एक इंटीजर पॉइंटर लिया, उस पॉइंटर का नाम हुआ yptr. उस yptr वाले पॉइंटर में हमने एड्रेस ऑफ y को रख दिया. अगर y की एड्रेस 6 लाख है तो फिर पॉइंटर जो y को पॉइंट कर रहा है उसकी वैल्यू क्या हो जाएगी, 6 लाख हो जाएगी, राइट? और yptr भी तो एक वेरिएबल ही है, तो उसका भी एक एड्रेस होगा, तो उस एड्रेस को हमने लिख दिया है 5 लाख. एंड these numbers 6 lakh and 5 lakh, they are just for illustration purposes. It is just for your understanding. In reality the numbers are much more complex, वो hexadecimals में होती है. So this is just for illustration purpose, for your understanding. So let's discuss the features of pointers. Pointers provide direct access to what? Memory, as it stores the address of another entity. See, here pointer ptr is pointing towards variable I. So it stores the address of I as the value of PTR. So obviously it is accessing the memory directly. आप जब address of I को store कर रहे हो, आप memory location को ही तो store कर रहे हो ना PTR में, तो it provides direct access to memory. Yes, pointers refer to a memory location. Again, the same thing. Here, I is a variable. I has an address. That address is its memory location. And this memory location is accessed by PTR. This is the same thing only. Pointers reduce the storage space and complexity of the program. अगर हम एक pointer assign करते हैं एक पूरे array को, using pointers we can access every single element of the array using one single pointer. We don't have to individually declare separate pointers to access the separate elements. Using only one pointer, just one pointer, we are going to be accessing the entire array. We will traverse all the array elements. So whenever we increment the pointer by 1, we will be traversing to the next location in the array. Reduces the execution time of the program? Yes, because we use dynamic memory allocation. Dynamic memory allocation means we allocate memory during runtime, so there is no static memory. So there is no wastage of memory. This is the reason the execution time of the program reduces. It provides an alternative way to access array elements. TR will always point towards the first element. So if I write cout array at element 3, we know the value will be 4. And if we write cout ptr plus 3, that means ptr from the first location 1, 2, and 3, that is at point element 4. So this is the reason it provides an alternative way to access memory. That means ARR at ith position is same as pointer plus I. That is why it provides an alternative way to access array elements. Pointers help us build complex data structures like linked lists, queues, stacks, trees, graph, etc. So it will be very difficult for traversing complex data structures like graphs and trees. So we use the help of pointers. Pointers point towards one memory location, and by incrementing pointers, we can traverse the different areas of a complex data structures. Whenever we have to access the address without using pointers, we will be only using the address of operator. So if I write int a is equal to 10, I will simply print the value of a, writing cout value of a is equal to a. So output will be 10, and cout address of a, we will just mention ampersand in front of a, and whatever the address of a, we will be getting it. See here in the output, the value of a is equal to 10, and address of a, it's a hexadecimal number, so you will be getting it. If we have to access address by using pointers, we write the name of the variable, then we declare a pointer variable, that is p. We assign the address of variable a to pointer p. Then we simply print the value of a using the pointer p. So whenever we have to access the value of a variable using pointers, we will use the dereferencing side. When we write asterisk p, we are referring to value of a, that is 10. So answer will be 10. Then when we write cout address of a, we simply write p because p is already assigned the address of variable a. So whatever will be the address of a, we will be getting it through p. Note, we have not used any asterisks here. It is only p. There are basically 4 types of pointers in C. One is null pointer, another is while pointer, then there is void pointer, then there comes const pointer, and pointer to a constant is also a topic that I'm going to discuss. So let's view them one by one. Any pointer which we assign the value null is called a null pointer basically. It is always a good practice to assign null value to a pointer variable in case we don't have an exact address to be assigned. Why? Because otherwise we would be allocated any random memory address. The value of null pointer is 0 defined in several standard libraries. So it is just a good practice to initialize pointer with null. Here in this example, we write int ptr is equal to null, which means we simply mention that the pointer of integer type has been initialized with null. And when we try to print the value of this ptr, we will get the result as 0. Pointers which are not initialized during its definition and they hold some junk value but which is a valid address are called while pointers. Now every uninitialized pointer is a while pointer. As the pointer gets initialized and they start pointing to some variable, it is defined as a normal pointer, not a wild one. So here in this stage, when I write int ptr, this is what? This is a while pointer. Then when we write int a is equal to 10 and then we assign the address of variable a to pointer ptr, then it has been initialized, right? You have assigned a value. So now ptr is no more a while pointer. That means at this stage, when the pointer is left uninitialized, it is called a while pointer. This is a while pointer. Now suppose in a program you have to declare integer pointer, character pointer, float pointer, then we have to declare three separate pointer variables because I have told you earlier that the data type of the variable and the data type of the pointer must be the same. So if you have three separate variables, one integer, one character, and one float, then you must have three separate pointers, integer, character, and float to access it. But using a void pointer, we can get rid of this limitation. इसका मतलब ये है, अगर हमें एक ही pointer को use करना हो to point at separate variables of different data types, then we use a void pointer. That means एक void pointer के through हम different data type, different variables of different data type को access कर सकते हैं. This means that void pointers have great flexibility. Obviously, because one pointer you can use to point at different types of variables having different data types. So it makes your program much more convenient, flexible, and faster. There is a payoff for this flexibility also. These pointers cannot be directly dereferenced. We have to explicitly convert this pointer to the desired data type before being dereferenced. A variable int a, which has value 10, and a void pointer which stores the address of a, and we directly try to print the value of ptr using asterisk. We cannot do it because we have not changed the data type, because we have declared the pointer as void. So how will the compiler get to know whether the address it is pointing to is an integer, character, float, double, or whichever data type? So how does the compiler get to know? So for that, we have to explicitly change the data type. We have to explicitly mention the data type. So this program will give compile time error because void is not a pointer to object type. In this function main, we take a void pointer ptr, then we take an integer variable 10, then we take float variable b, which has value 2.5. Then we store the address of a in ptr. So here in this case, we have mentioned the type int. So when pointer points to int, and we know pointer is pointing towards a, which matches with int, it will print 10. So first output is 10. Then we store the address of b in pointer ptr again. And now we print the pointer's value using float. We explicitly mention the data type float and we know that the pointer is pointing to b now. Float matches with data type of float b. The output is 2.5. A const pointer is a pointer that cannot change the address it is holding. In other words, we can say that once a constant pointer points to a variable, that it cannot point to any other variable. It means कि अगर हमने constant pointer declare कर दिया है using const keyword, we cannot change. हम उसके अंदर की जो value है, जो address है उसके अंदर जो stored एक बार, हम उसे वापस से दोबारा change नहीं कर सकते. The syntax of const pointers is type of pointer, that means data type of the pointer, const keyword, and the name of the pointer. Example, int const कीवर्ड एंड pointer name. हमने डिस्कस कर लिया कि constant pointer जो है उसकी हम एड्रेस जो उसके अंदर स्टोर्ड है हम उसे चेंज नहीं कर सकते. So in this example, in this function, we are taking two integer variables, var1 जिसकी value 0 है and var2 जिसकी भी value 0 ही है. So we have taken int const ptr is equal to address of variable 1. We are writing ptr is equal to address of var2. Now I have told you that const pointers will store the address once and we cannot change the address again. The value that the const pointer is holding cannot be changed again. So हमें इसमें error इसीलिए मिल रहा है because हमने एक बार address जब assign कर दिया है हम उसे दूसरी बार address assign नहीं कर सकते. This is the reason we will get an error in this program. So how do we correct it? This is the correct program. The two variables of int type var1 and var2 initialized with 0. Then we declare a const pointer which stores the address of var1. We know that since it's a const pointer, we cannot update the address of ptr anymore. But we can definitely change the value of var1 using pointer ptr. We know that using the dereferencing operator, we can access the value of the variable ptr is pointing towards. So we will update the value from 0 to 10. As a result, when we print asterisk ptr or dereferenced ptr, we will get the value 10. Note, we are changing only the value of ptr. We are not changing the address. Now pointer to a constant. This is the exact opposite of constant pointers. That means in this case, we cannot change the value of the variable it points to. Instead, we can only change the address they point to. These type of pointers can change the address they point to but cannot change the value that is kept at those addresses. इसका मतलब ये है कि हम इसमें address तो change कर सकते हैं but जो value है of the variable the pointer is pointing to उसकी value नहीं change कर सकते. इसका syntax है const data type of the pointer asterisk name of the pointer. Example const int asterisk ptr. In this program, there's this variable var1 जिसकी value 0 है. We declare a pointer to a constant जिसमें हमने address of var1 assign कर दी. अब जब हमने address of var1 assign कर दी, तो obviously once the memory is assigned, then even the value that is pointing to becomes 0 because initially var1 is 0. So when we try to update ptr now with 1, we get an error because once you give a value, you cannot change the value. The pointer which cannot change the value of a variable it points to is called pointer to a constant. Hence, it will give you a compiler error. Though we cannot change the value of the variable it points to, we can change the location it points to. This is an integer array of two elements. This is element at 0 and this is element at 1. We declare a pointer to a constant. We assign the address of the first element of the array to the pointer and then we increment the pointer. Once we increment the pointer from here, it starts pointing to the next location of the array. That means it traverses to the next location of the array, which is 20 ptr. So when we try to print dereferenced ptr, we get the value 20 because now the pointer is pointing to the array element at position 1. So we get the output 20.
Thank you. In the next video, we will be discussing constant pointers and pointer to a constant.